Hello everyone. Today I am going to discuss one problem from CSES problem set, and along with that we'll discuss one string algorithm. So what is the problem? The problem is palindrome queries. So the problem statement is quite straightforward. We are given a string that consists of n characters between A to Z, and we also have m type of queries or q queries, you can say. There are two types of queries. The first query is that we have to change the character at position k to x, and the second query is that second type of operation is that we have to check if the substring from position l to r is a palindrome or not. So let's take this example. Let's copy this here, and let us try to find out the answer for each and every statement or each or every operation. So initially the first operation is that is type 2 operation, where we have to find that the substring from length 3 to 5 is a palindrome or not. So here the length of 3 to 5 is BAB. BAB is a palindrome. So the answer for this will be yes. Now the second operation is the update operation. Update operation means that we have to change the third character to x. Okay, so we have to change this third character to x. Now after that we have to check the third operation is that we have to check 3 to 5 is a palindrome or not. 3 to 5, that means 1 2 3 4 5. So now it is xab, so the answer will be no here. Now 1 5x, we have to change the fifth character to x also, so now this will be x. Now after that the fifth operation is that we have to check the 3 to 5 is a palindrome again or not. So in the first operation the substring was bab, so it was a palindrome, yes. Second operation the substring was xab, so it was not a palindrome, so the answer is no. But the third operation again the palindrome is the substring is xax, so the answer is yes. So the our answer is yes, no, and yes. So let's check. Yes, the answer is yes, no, and yes. Now how should we approach the problem? The brute force way to solve this problem. So let's discuss brute force solution. The brute force solution is that for each operation each update operation will update the value, and for each query operation, what will we do? We will just find that from L to R. We'll check that substring L to R. We'll find the substring from L to R. Let's call it S. Now we'll check S is equals to S rev or not. So we'll reverse the string S, and we'll check that S equals to S of rev or not. So overall time complexity is that for this operation the time complexity is order of n, and for the update operation the time complexity is order of 1. Okay. Now let's say all are query operations. So all are query operations. That means the overall time complexity will be, there are q queries, let's say, and the length of the string is n. That overall time complexity will be order of q into n. Okay, order of q into n. So let's check the constants now. Now n and q both are 2 into 10 to the power 5. So order of q into n is not definitely not possible. So we have to think something better. Okay, we have to think something better. We have to solve this problem in order of q log n, kind of q log n, or q order of q. So order of q is definitely not possible. We have to solve the problem in q log n. So how we are going to achieve that? So for achieving that, we have to find that how we can compare two strings without comparing each and every character of the string. Okay, so we have to compare. Let's say we have some string s and another string t. Now without comparing each and every character of the string, how we can check that these two strings are equal or not? So that is called hash. We have to find the hash of string s. Let's call it hs, and we have to find the hash of string t. Let's call it ht. So if these two are equal, then we can say that these two strings are equal. So for finding hash, what are the different types of algorithm? So for finding hash, the one type of algorithm is the rolling hash. I forgot. I think that is called Rabin Karp algorithm. So how we are going to find the hash of some string? I will provide the link of the string hash in the description box. You can check that out. So, but let's discuss about this algorithm once. Let's say we have some string ABC. Okay, ABC. So there are multiple ways to find one hash. So one popular way is to use base 26 indexing. Okay, so ABC, A in base 26 will be 1. Okay, and B in base 26 will be 2. C in base 26 will be 3. Okay, similarly Z, if there is some Z, the base 26 value of this will be Z. So for this string we have 1 2 3. So now uh, the leftmost values will have higher precedence. So how we compute the values of normal binary integers or even normal 10 based integers. So the power of this will be 26 to the power 0. Okay, 26 to the power 0. The power of this will be 26 to the power 1, and the power of this will be 26 to the power 2. Okay, so the overall hash of this string will be 26 to the power 2 into 1 plus 26 to the power 1 into 2 plus 26 to the power 0 into 3. Okay, this will be the hash of the string. So this is quite popular algorithm, Rabin curve algorithm, for finding the hash of a string. Okay, for finding the hash of a string. Now uh, this Rabin curve algorithm can also be modified for finding a hash of a substring, or we can say that when we are uh, performing some window operation, right? So let's say instead we have something like ABCD, right? We have something like ABCD. Now we have to find the hash of every substring of length 3. Okay, so let's say we have computed the hash of this. Okay, ABC. Okay, now we are moving we are moving our window forward, so we have to add d from the window, sorry, we have to add d to the window. And what we have to do, we have to subtract the a to from the window. So how are we going to achieve that? Okay, so for achieving that, the famous algorithm, famous trick is that we have to take the let's say we are deleting something, right? So let's say we are deleting s of l. Okay, so this will be s of r, this will be s of r, and this will be s of l. So here you can see that s of l has a power of 26 to the power, s of l has a power of 26 to the power k, where k is the length of the window, 26 to the power k minus 1 actually. So we have to subtract 26 to the power k minus 1 into s of r. Okay, we have to subtract this. Now after subtracting this will be hash, right? This will be hash. So 26 to the power k minus 1 minus s into s of r, we have subtracted this. Now after that, the value will be 26 to the power 1 into 2 plus 26 to the power 0 into 3. But here the base of b previously was 26 to the power 1, right? But now it will be 26 to the power 2, and base of c will be 26 to the power 1, right? So what we have to do after deleting this from h, so after deleting h minus 26 to the power k minus 1 into asr, we have to multiply this with 26, and after that we have to just add s of l here. So this will be the modified hash. Okay, so the modified hash h bar will be nothing but this h minus 26 to the power k minus 1 into sr, and after that we have to change the power of the remaining elements, so we are multiplying it with 26, and we have to add sl here. Okay, that will be the modified hash. Now this is the gist or the basic of string hashing. So we are going to use this string hashing to solve this problem, and how we are going to solve this problem using string hashing, that is the important part. Okay, so let's say we are maintaining, let's say there are no update operations. Okay, there are no update operations, let's say. So let's say we have some font hash, we have some string, right? The abcd. Okay, so abcd. So let's say we have some hash map where we have, let's say we give l to r. Okay, so l to r. Okay, there is some hash map where we give l to r, and it will give us the front hash from this. Okay, so let's say we have passed 1 comma 2. Okay, we have passed 1 comma 2, so it will give the hash of ab. Okay, so let's say we have some hash map, let's call it front hash fh. So if we give fh of l to r, we will get our front hash. Now let's say we have some another hash map which is called back hash. Okay, so if we give uh, if we try to compute back hash, so what does back hash means? Back hash means that we are reversing the string. So after the reversing the string, it will be dcab. Now we will give back hash of 3 to 4, right? We have to give back hash of 3 to 4. It will give us the value of ba. So it will give us the value of ba. Okay, now if front hash of L2R is same as backhash of the backhash in the reverse string. So if the in the front string, in the forward string, it is L2R, in the backward string it will be nothing but n minus r to n minus l, right? You can check this, right? If in the forward string, if it is L2R, in the backward string it will be n minus r to n minus l. So if the front hash from L to R is same as back hash from R to L, N minus R to N minus L, we can definitely say that this part A to B, L to R is a palindrome, because it is the hash is same from front and the same from back, and that is the definition of palindrome. Okay, so that's why we have to find the if h of L to R and back, bh of N minus R to N minus L, and we will get our desired answer. Okay, now here comes one interesting part, that we are not going to find L to R. Okay, we are not going to find hash of every possible substring in the forward direction and backward direction. That is one problem we have. And the second problem we have is there are some update operations. So for that, we have to add another data structure, which is definitely a segment tree. Okay, so which is definitely a segment tree. So let me clear all the things up, and let me gather some example to explain you the segment tree. So I am not going to explain the basic structure of the segment tree, but let me explain some part of it. So how does the segment tree works? The segment tree works in such a way. Let's say we have some range or segment L to R, right? So L to R will find the mid of this. Let's call it that mid. Okay. So we will find some value from L to mid. We will find some value from L to mid, and we will find some value from mid plus 1 to R. Okay, we will find some value from mid plus 1 to R, and by finding this from L to mid, and let's call it h of left. Okay, h of left, and we will find some value in the right section, h of R. So with the value of h of L and h of R, we will try to find the value of the entire segment L to R. So how will it work? So let's say h of L gives us h of L gives us the hash in the left part, and h of R gives us the hash in the right part. Let's say we have something like ABCD. Okay, let's say we have something like ABCD. So hash from the right part is, let's say, HA. So HA will be nothing but 26 to the power 1 into 1, 26 to the power 1 into 1, plus 26 to the power 0 into 2. Okay, 0 into 2, and here the right part will be nothing but 26 to the power 1 into 3 plus 26 to the power 0 into 4, right? Now how we are going to compute h with the help of h and hr. So here you can see that h is hr. Okay, h is hr, because this will be 26 to the power 1 into 3 and 26 to the power 0 into 4 only. But when we are adding AB to the string, here the power of A will become 3 and the power of B will become 2, right? Because the power will be, the base will be 3, 2, 1, 0, right? 26 to the power 3, 26 to the power 2, 26 to the power 1, and 26 to the power 0. So the right string will, the hash of the right string will not change, but the hash of the left string will be multiplied by uh, 26 to the power 26 to the power the length in the right string. So let's call it length of right. Okay, so, so hr plus hl into 26 to the power r. Okay, that is the only important thing we need to know about segment tree in the given problem. The other part of the segment tree is quite straightforward. That is a basic segment tree. So if you don't know about segment tree, before moving to the code, I will suggest you to just try to see different videos or articles about segment tree, and try to get the basic understanding how segment trees work, and how the basic, what will be the basic structure of the segment tree, and how we are going to update a specific index, but because that will also be needed when we are updating a value at a particular index, and how we are going to query this particular range. Okay, so now I will jump to the code, but before that, please rewatch the video again, and also please watch some videos of segment trees. Okay, so let's jump to the code now. You'll understand the entire concept clearly. Okay, so now this part is for a segment tree. So I have defined a class of segsum. Segsum is nothing but segment tree with sum as of addition. So here in the segment tree, I am passing. That is another important part that is needed in this problem statement, is that we are defining a class segment tree, right? But if we declare some vector or some array inside this segment tree, that will be initialized in the stack, but we don't have that much amount of stack memory, so we have to declare some global variable. Okay, that's why I have declared two global arrays of segment front and segment back, and in the segment sum class I have provided the pointer to the segment array. Okay, that's why in the constructor I am taking the length of the segment tree, which is n, and I am taking the reference. Okay, reference or pointer you can say. So I am initializing segment with segment tree. This is just part of a C++, what I can say, C++ only. So you can ignore that part also. Now this part is for updating and this part is for query. I will explain why this query part is slightly different from the other segment tree boilerplate you have noticed. Okay, so now let's discuss about the update first. The first section is that the range does not overlap. Okay, the index does not overlap with the given range. So in the update of a segment tree, we take some range from, let's say, SS to AC, and if we check that the current index which we are trying to change is within the index or not. If it is within the range, we'll check that if this is in the left part or this is in the right part, and if SS equals to AC, then that means that we are at the given index. This is equals to index, then we will update. Okay, so here uh, if SS is greater than AC, that means this does not overlap, so we'll just return. Now if SS equals to AC, that means SS equals to AC and this is equals to index, so we are updating segment v value to val. Okay, now if index is greater than mid, then we will go to the right part, and otherwise we will go to the left part. And after that, this part is important, I have already explained that segment 2 into v plus 1 will be the right part, so h of r will not get updated. Here you can see that h of r is not getting updated, but we have to multiply h of l with 26 to the power AC minus mid. So I have already calculated the power of 26 values, 26 to the power 1, 26 to the power 2, like that. So that's what we are going to use here. Okay, and we are updating the value of segment V accordingly. So this part is for the update function. Now query is slightly different. Why we are returning an array of int comma 2 here? Okay, that is important. Now let's say we try to find some value from L to R. Okay, if you know about segment tree, you might know that we have two types of range. One is the segment range, SS and SL, SS and AC, and another range which is QS and QE. Okay, QS and QE. Okay, now there there could be some possibility that uh, we are taking some range, but in the right part there is no overlap with the current range. Okay, so let's say SS and AC is like that, but QE is on the right side, right? Is on the right side, so that does not always mean that we will get all the characters here. Okay, so that's why with the hash we are returning the hash on also from the left part and the right part. We will also return the number of characters in the current range. Okay, let's say in the right range, let's say there are CR number of characters, and the left range there are CL number of characters. So when we are modifying the value of here we are multiplying it by AC minus min, because we already are sure that there are AC minus min number of characters, but here we are finding what are the number of characters that matches in the right part. Okay, that's why we are returning the number of characters in the left and the number of characters in the right. So left 0 is the hash in the left into pw of right of 1. Right of 1 means the number of characters in the right, and plus right of 0 is the hash in the right. So this part is similar to this part. Okay, but instead of already pre-computed value of AC minus min, we are using right of 1. Okay, after that we are returning hash comma total number of characters will be total number of characters in the left and total number of characters in the right plus. Okay, so this part is the segment tree, that is only part needed here. Now here I have initialized the PW array, power array, and we are iterating over every character, and we are changing we have two segment trees, right? One is forward segment tree and another one is reverse segment tree. So we are changing the value of I plus 1 index with si minus a plus 1 in the forward segment tree, and in the reverse segment tree we are updating the value of n minus ith index, the reverse index. We take the reverse, so L will be reversed to n minus l plus 1, kind of that. Okay, to use one best indexing. Uh, that's what we are doing here. Now, if for the type order operation, we are again updating the similar value of index in the forward segment tree, and in minus index plus 1 in the reverse segment tree, right? And for the update operation, we are finding the front hash using querying in the front segment tree with L comma R value, and query in the right segment tree with n minus R plus 1 and n minus L plus 1 value. If the front hash equals to reverse hash, we are printing yes, otherwise we are printing no. So I will try to provide the link of basic segment tree article in the description box. Also, I'll provide string hashing, Raven, carb algorithm, some article in the description box. Also, I'll provide the link of the code in the description box. You can check that out. If you have any doubt in any part of the video, you can rewatch the video or you can write in the comment section. I'll try to reply each and every comment. If you find this video helpful and also the series helpful, please share the series among your peers and also like the video and subscribe to my channel. Thank you.